Thanks, Boise, and ahoy from Boston. I don't hear myself, so I'm kind of wondering what the story is there. Or am I the presenter? All right, so now I have to go here and share my desktop, which, can you see the slides? Can everybody see the slides? Check, check, 1, 2, 3. Hello, Cleveland. So thanks, Boise, for the introduction. So today's talk, let's back up to the beginning, is the Android SDK Intro. So what we're going to do here in the 20-25 minutes that we've got is show you how to, the bare minimum that's required to get an Android app so that it's emotion enabled. And we've done a lot of work. We've gone through 3 major iterations of the API, and I think each one has gotten progressively easier to integrate in, because we recognize that one of the big hurdles is, okay, I have an app and I want to emotion enable it. I think it would be cool. How do I do that? And so with our 1.0 API, it wasn't exactly easy to do. And so we've been working with each release on making the SDK a little simpler, making the packaging a little simpler, making the hurdles to getting into it a little simpler, even at the business level. So what we're going to do today is basically talk about the API architecture so that when you get into the code, you'll kind of recognize where you are and you won't get lost in the API. We'll talk about the 4 different ways to use the SDK. We basically have 4 different API signatures that you can use for different use cases, and we'll talk about, how to choose the right one. Then what we'll do is go into what I would call a sort of live example. Basically, it's like one of those cooking shows where you put the turkey in one oven and you pull the cooked turkey out of the other oven. What I've done is prepared a simple application, probably the most simple application, and then I'll show you step by step how to emotion enable it, just so you get a sense of how easy it might be. Now, in the real world, we've actually got examples up in our GitHub page that do things like, handle all of the other Android stuff that I'm not going to go into in this talk, but it just shows you how easy it might possibly be. And then to wrap up, I'll point you to some resources on the web that I think might be helpful, because we've put a lot of effort into our documentation. So to start out with the architecture, basically, as I mentioned, we have 4 basic ways of using the SDK to handle lots of different use cases, but the basic architecture is similar in all 4, so that it's consistent across all 4 use cases. And basically, it's a callback-oriented architecture. So the flow is, and I've got a picture on the next slide, you configure the SDK, so you're driving, and then one of the things you configure is you give the SDK callback methods that it can use to tell you about stuff, so that when something interesting happens, the SDK calls back, and then you can decide what to do at that point. You can either go into the SDK to ask for more data, or stop the SDK, or whatever suits your particular use case. So in a UML drawing, I don't know if anyone uses UML anymore, but I'm old. So here you go. You start out basically with a client in the SDK. The client is your code. First step is initialization. So you drive. The client decides when and how the SDK is supposed to run. It's basically in control. Then at some point you start the SDK, and this is important because you can initialize it and leave it in a idle mode until you're ready to use it. Then at some point stuff happens, and this callback is your code. And the SDK calls back into your code, and then basically you can decide what data you want. So the SDK is going to say, hey, I've found some faces. Do you want to know about them? And you can say, well, maybe I want to know about this one, but not that one. And then this goes on for as long as you think the SDK would be useful in your use case. And then if you want to, you can just tell it to stop, and it cleans up. So here are the 4 ways to use the SDK. And basically what we've done is come up with 4 different API signatures that we think cover the majority of the use cases that people are going to use the SDK for. So the first one is the camera-driven use case. The way this works is that you start up the SDK, and then the SDK actually manages the onboard camera. You can tell it which camera to use, and then the SDK starts that camera and starts pulling frames off the camera in real time, processing them, and giving you callbacks. This API is I think, the simplest, but it gives less control. So the next API is all about client control. Basically, the client acquires the frames however you're going to acquire them. Maybe you're pulling them off the network. Maybe you're getting them directly from the camera. It doesn't matter. But you push the frames into the SDK. So you have ultimate control. This is a little more complicated. The client-side code has a little more responsibility. But ultimately, it has the greatest amount of client-side control. Then there are two other kind of, I guess I'd call them miscellaneous ways of using the SDK. You can use it to process pre-recorded video files, pre-recorded photo files. And again, all of these use cases basically work the same with the callback approach, where you tell the API to do something, the API calls back, and then you ask for the data that you want to use. The last two, I guess I'd say, are somewhat less common, but we added them for completeness. So now what we're going to do is go into each in just slightly more detail so that you'll know sort of where to go on the developer website. So the camera-driven approach is called Camera Detector. And actually, I don't need to talk a lot about it here because that's what we'll use for the quasi-live coding demo. So the camera detector is, as I mentioned earlier, it's real time. It basically drives the camera and frames are processed as they're captured. The SDK handles all the camera configuration and just calls back to you. So again, this is the easiest of the APIs to use, but it has somewhat less client control because all you can basically do is tell it to go. The frame detector, by contrast, again, puts a little more of the complexity onto you, but it gives you greater control because basically you're pushing each frame into the SDK one at a time, and then the SDK is processing that frame as you give it to it, and then providing you with the results. This is great, for example, where you're getting frames from somewhere other than the camera. So, for example, if you have a video chat app that you want to motion enable, or if you have some telepresence app, frames are coming in off the network, and so you can take the frames, pass them into the SDK as they come in, and get immediate results. And then we've got the two sort of miscellaneous approaches. The video detector, basically you give it the path of a file in local storage, and it runs through that file, processes each frame, and calls back to you on a frame-by-frame basis. And then the photo detector basically takes a single frame, processes that, and again calls back. And so it's a reasonable question that you might ask, sort of, why do we have these two things? And partially it's under the hood optimizations. So the video detector, if you know you're going to have a bunch of frames that are temporally all one right after the other, you can do things to optimize both the speed and the accuracy. You can improve the speed of the face tracker, the interframe face tracker, so once you've got a face, it's easier to find the face in subsequent frames and faster. You can also improve the accuracy. You can baseline the face measurements and calculate deltas off of that. If all you have is a single frame, you don't have as much context, so there's no point wasting your time on those algorithms. You can just basically do the brute force approach. So again, those are the four approaches. We've got free running camera. Then another approach is you pass the frames into the SDK under your control, and then we've got processing video files on storage and photos on storage. So now let's do this. I'll take a quick sip of water, and let's move into showing you how to actually do the code. So what we're going to do is use the camera detector because, as I mentioned, it's the simplest API, and we don't have a huge amount of time today. But let me just give you an idea ahead of time of what we're going to do, so as we go along in the video, you'll be able to keep up. I'll narrate in real time, but this way you'll be able to understand what we're doing as we're doing it. So the first thing we're going to do is just go into Android Studio and create one of their little skeleton demo apps. It's a little thing with, basically one view, and we'll add another view for the video. Then we'll configure the Gradle build system to use the SDK and wire it into the metadata. This is one of the things that we've done fairly recently, again, to make it easier to use the SDK. We used to tell you had to download a zip file and crack it open and put files in various places in the disk. Now I'll show you it's really simple, and Gradle goes and gets the SDK for you and installs it for you. So basically you just add a few lines to your Gradle files, and that brings the SDK down and builds it into your app. We'll add a view for the camera preview. It tends to be a good idea to give people a view if you're shining a camera on them. People like to see what's going into the camera. There are instructions on the developer website of kind of how to work around that, but we generally prefer that if you're shining a camera on someone that you show them what the camera is seeing. So we'll do that, give you a little video preview. Then we'll write the callback skeletons, and that's the mechanism by which the SDK gets events back into your code. We'll write the initialization code that configures the detector. This will set it up in a free running mode. And then we'll implement the callbacks and run it and see what happens. So without further ado, let me see if I can move over to the video. Do you guys see the video? Okay. Imtiaz is saying he sees the video. So now I can start it running. So let me establish a little context first. So what I've got over on the left side of the screen is basically Android Studio version 2.2.2 evidently. It's just whatever one I got. And then on the right side of the screen is a mirror of the display from my phone, so that you can see what the phone is showing you. So let's get started. So the first thing we'll do is again, this is just a little demo app, just a simple, minimal application. We go as far back as API 16, so I think you can cover 95% of all devices. Here's simple activity, just basically one screen, and then this is where we can do things like fast forward so that we don't have to watch Gradle churn on building its stuff. So as I mentioned, the first thing we'll do is go into the Gradle build files to configure it to use the software development kit. And the cool part about that is that means that you don't have to download it yourself. Gradle will do that for you. So what we're doing here is telling Gradle where to get the code. So you've got maven.affectiva.com as our download site. You could actually go there by hand if you wanted to, but now what we're doing is telling Gradle, here's where you go to get this resource. Now what we'll do is tell Gradle that this app depends on a specific version of the Affectiva SDK. Here we go. So we're saying this depends on Afftex SDK 3.1.2, which is the current version at the moment, but as new versions come out, you can just change this version number to upgrade. Obviously, if we go from version 3 to version 4, then you might anticipate some API breakage, but as long as we're in the basic 3 series, you should be upward compatible. Moving right along, now what we're doing is adding declarations to the manifest, to the application manifest. This one is a little bit housekeeping-y. Basically, it's kind of a weird Android thing that because we have a label and you have a label, we have to tell Android that yours overrides ours. It's kind of grotty, but unfortunate. Now we're basically saying, okay, here are the things that this application needs to do. It needs to access the camera, it needs to send things over the wire. So now that we have those declarations, the app can go ahead and it'll build. And looks like we're good. So now we can show you the basic code. What we're doing here is, I mentioned probably so many times you're bored hearing it that it's a callback-oriented architecture. So in Java land, what we're doing is saying that this particular class implements the callback signature, which will allow us to basically make the callback just a single method in this class and pass the instance that is instantiated of this class into the SDK. It just makes the code a little bit simpler for these purposes, but certainly if you want to implement a dedicated callback class, you can do that as well. So this is an image listener. It'll get events when image events happen. And now Android Studio is going to build the skeleton for the callback based on the signature. It's basically pretty straightforward, a list of faces. You can see, whoops, that obscures it. A list of faces, a frame, and the timestamp. So now what we can do is actually implement some of the other code that we need. So for these are just placeholders for the various stuff. You need to instantiate a camera detector, and then we have a couple of views. One's for the camera preview, and one's for just a little bit of text. We're just going to pull one parameter out of the SDK. I think it's the smile parameter, and so this is just where we're going to display that text on the screen. And then, yeah, Studio does all the imports for us and stuff. That's pretty cool. Now what we've done here, this is the initialization code. So what we're doing is instantiating a camera detector, passing in this instance. So that's the callback. And then some other miscellaneous configuration, like we're going to use the selfie cam and where the preview view is. Now let's see. We're also this is important actually. So when you configure the SDK, every classifier, every metric, every expression, every emotion costs a little bit of processing. And so we have methods that you can use to say, turn absolutely all the metrics and classifiers on. And they're great for messing around and figuring out how things work, but in production, you're probably not going to want to do that. So to be respectful of people's batteries, you're probably going to want to turn on only those emotions that you're actually going to use. It makes things a little faster, a little more efficient. So what we're doing here is turning on just the smile classifier, because that's the only one that we're actually going to use on the screen. And then another important thing is how fast you want to process. We don't want to just let it run freely at the full rate of the camera. Again, that's kind of wasteful of resources on the phone. So we're setting the process rate. And again, what I think is important is the idea that you can start with a baseline number, but you'll probably have to tune it for your use case. It depends on how fast the phone's moving, what context you're in, whether it's a phone or a tablet, the people's lighting, all that kind of stuff. Here, 10 is probably about right. We think 5 is about the minimum. You probably wouldn't want to do less than 5 because you'd start to miss expressions. And you probably don't want to let it run freely either. So here we'll just set it for 10. So now, because we don't have that text view, we'll add it in. This is the default. We're going to just go over that. So now we have two views. One for the text, that's this text view. One for the camera preview, that's the camera preview. And that's basically all we need. Now what we need to do is implement the callback. So onImageResults gets called when things happen. I'll make one little tweak here to make it slightly less ambiguous. It just uses list, and we'll say faces. Yeah, that's a little more clear. So we basically find the text view. If we have no faces, then we say no face. And then if we have a face, if we have one or more faces actually, we just get the first one and pull out the smile. So face.expressions.getSmile. That's going to get just the smile value, and then we splash that up on the screen. So now I think all we need to do is start the camera detector. We haven't written any code that launches it and tells it to go. In this case, we've got this onclicklistener, which is basically a little button that the application that the studio puts into the app, so that when you click the button, it'll start the detector rolling. So now basically we can build it and watch Gradle crunch for a little bit and download it to the phone and watch it go. And then you'll get to see your presenter in all his shaggy glory, because he's actually using the selfie cam here. Installing the APK. Yeah, I probably should have edited this out. And here we go. So this is the camera preview, this big black box, and the red email icon is where we're going to start. So I click on that email icon. Oh, my coworkers are telling me that the video's running behind the scenes. So let me stop the video, back it up to where I think you guys are roughly. Where are you guys? So you're basically ready to launch the application. Okay, so let's start again and see if WebEx, do you guys see the application going? Okay. So sorry folks, I was getting out of sync. So now we're just going to start the presentation. We're just going to start the app. Here we go. The app's going to launch. We're downloading the APK here. And now the app has launched. Let's just set this and give it a chance to catch up. So this black window is the camera preview. This red button starts the camera detector, and where it says "Hello World," that's where we'll display the smile value. So guys, yeah, just let me know if it starts lagging again, because that's kind of annoying. So I'll click on that, start the preview. Whoa, that's me. And now I will smile, which I rarely do, but look at that, it actually works. So, and that's a good example of, so I turn away and we lose the face, but now I can smile and it picks up the face again. So this is me. Okay, so there's a basic application. That's about the bare minimum, as you guys are probably already thinking, and you're right, that, wow, there's a lot of stuff you didn't cover, like the dynamic permissions API for, asking to use the camera, camera aspect ratio, phone rotation. So to see an app that handles all of those things, you can go to our GitHub page. So here are some helpful resources. Basically, the GitHub that I mentioned is right here. Basically, we have an example application for each one of the 4 types of detectors. So you can get an app download it, use it. They're permissively licensed, so you know, they're not copyleft or anything, so you can just grab those applications, fire them up, use them. And then there's actually a fifth demo application called AffectX.me, which you can get in the App Store, which is rather more complicated. It lets you choose the classifiers and all that stuff. Of course, developer.affectiva.com is the kind of hub of all of our documentation. If you need to ask questions, you can ask them on Stack Overflow. That way, you can also query questions that other people have asked. Someone might have asked your question before. If all else fails, feel free to send us an email at sdk@affectiva, and we'll try to get back to you as soon as possible. And then I also put, for the sake of completeness, the Android developer portal, so if you need to learn about things like using a camera or that sort of stuff, that's a good place to do it. So now, what's the plan, guys? Where do I find questions? Yeah, but where do I go to see the questions? Participants, chat, manage panels, Q&A. Hi, please, how can you support researchers? In the emotion field, that's Amina. So we love to support researchers, actually, because obviously this company came out of research. You know, we're a spin-off of the MIT Media Lab. And so basically what I would suggest is, you know, get in touch with us and let us know what your research is and what you need from us. I think the two things we have that we can potentially offer to researchers that could be interesting, one of which is obvious, it's the SDK. But then the other one is that we also have a massive body of ground truth data of faces showing emotions and expressions. And so we can talk about maybe sharing some of that. I know we've already made one data set public, so we can point you to that data set. And then we have other data that we could talk about, or if you have a data set, maybe we could do some processing. But we definitely want to help researchers do their research. I guess that's it then. Any other questions while we're looking at questions? In that case, thank you. Appreciate your spending the time to learn about Android and our SDK. And again, feel free to use these resources if you get into building your SDK app and you have any questions.